All right. Hello, everyone. Hello, Mark, who said good morning. East Coast, I guess. Or maybe just one of those people who believes in, what's it called? Standard greeting time, where it's always morning when you say hello to people and always evening when you say goodnight. That's also reason. Um, let's see. So I still don't know if I'm gonna do Emacs or VS Code today. But we'll start with Emacs. A couple things I wanted to look at from yesterday's puzzle. Oh, Sweden. Okay. Well, that's more morning than the East Coast anyway. So I made, as I often do, some changes to the code after publishing. Right. So this was my commit where I actually published things, and I found a bunch of tiny little fixes. And we'll just look at all of them combined, not really sharing anything. Git diff this commit. One thing I did was I added a link to this channel in the README because people are just like finding this shit on GitHub and being like, hey, what's up? I've heard from two different people so far, one in real life and one on GitHub, who was like, oh, I saw on GitHub that you're doing Advent of Code. And someone asked a question about my code, and I was like, well, I should just link them to the channel, and then they would have an answer. But so I added that. Not much of a big deal for you guys, of course. The other thing is, I forgot, you can just derive traversable. It's just like functor unfoldable. You don't have to implement it. It was, I think, good practice to do it because it gave me a slightly better understanding of how traversable works. But we get all of the pretty ways we had of interacting with 5 with a little bit less work. We didn't have to write this because GHCI will write it for us. And one person who had asked remarked that board could also be traversable and asked me how to make it traversable, and I did. We won't go too much into that, but you can. It was kind of slightly. It's an exercise for the viewer. That's my claim. The other thing is I wrote a few of these little helpers, which I had specialized to regex, but actually could have been more general, right? Sep by can apply to anything that's alternative. It needs alternative because of many. Anything that you can like choose A or B. For example, either parse delim app p again or parse nothing. That's kind of what many does. So that could work for any alternative. Doesn't make a difference in our implementation here, but sure. I'm surprised actually this doesn't exist somewhere because like it does exist in each parser library. Like okay, you can import it from parsec, but there's not like a general one, which I don't know. You might imagine exists for other alternatives. And then this 5 times, I realized it doesn't have to be regex. It can be any applicative. So even more general than sep by. It applies to anything that's applicative. Anything that's alternative must also be applicative. So this is less general. It applies to fewer types. That is to say, sep by is less general. And I just made a few little improvements here. I wasn't sure about this winner code. Like, obviously any all is nothing was repeated. Should I extract it out to a reused thing? I don't know. Whatever. It's not a big deal either way. But I do think this is a slight improvement aesthetically on the mark function. So instead of creating a just value and comparing the input, the mark on the board with that just, I just leave X as it is and I pattern match. And if I get a just, then I compare the unwrapped value with the integer that I had. And then if that didn't match, either because it wasn't just or because they were different numbers, then I just say, okay, leave it alone. So that's a slight improvement, I think. All right. I think that brings us to Advent of Code, day 5. Let's get started. Well, let's read it anyway. Day 5, hydrothermal venture. Oh, also I should note, I'm pretty tired. I got my booster shot yesterday. I just took a 2-hour nap. And I'm a little feverish and also achy today, so I might be a little bit low energy. We shall see. You come across a field of hydrothermal vents on the ocean floor. These vents constantly produce large opaque clouds. It would be best to avoid them if possible. They tend to form in lines. The submarine helpfully produces a list of nearby lines of vents, your puzzle input, for you to review. For example, so there's a line from 09 to 59, I guess? 80 to 08, 94 to 34. Are these always, No, there's at least one that's like a diagonal line, right? This one here goes from 64 to 20. Okay. They include the points at both ends. Okay. For now, consider only horizontal and vertical lines. Lines where either the x's are the same or the y's are the same. Okay. What's with this 2? Where is it? That's at 5, 4? Or no, this is 0 indexed, so it's 4, 2. We have 2 different. Do we have a line segment that's just 4, 2? Or is it? Am I crazy? XY to XY. X is to the right, so it should be 2. Oh, no, 3, 4. The 3, 4 goes to 1, 4. And also to 9, 4. Okay, so that's why they're showing this here. Because there's a line from here to here, and there's also a line from here to here. So this point is on both lines. I figured that's what the 2 was about, but okay. This diagram, the top left corner is 0, 0, and the bottom right corner is 9, 9. Each position is shown as the number of lines which cover that point, or else dot if no line covers the point. To avoid the most dangerous areas, you need to determine the number of points where at least 2 lines overlap. Okay. So let's look at my input here. As you might expect, it's a lot of numbers, and it's like they range between 0 and 1,000 roughly. Okay. So what it seems like might make sense would be to store a 2-dimensional array ranging from 0 to 999. I don't think there's any thousands in my input, are there? No. Is there a 999? No. But okay. I mean, I guess I don't there could have been 1001 and I would have missed it. We would, if I pick too small a number, we'll find out when we get a runtime crash, right? But the other thing is, like, we don't really need an array. We could just use a map from pair event to whatever, right? And then I don't have to worry about like any of this array shit. Yeah, that sounds better. We could use a map from int to map from int to whatever, have a 2-layer deep thing, or we could just use the map from tuple. I don't have a strong feeling about it. Since we're going to be accessing things not in like particularly row major or column major order, I guess a tuple seems a bit nicer. Maybe? All right. So let's grab this and get to day 5. There's my input. Let's look at day 5. One of these days I'm going to remember to turn off that that thing permanently. I probably don't need lambda case either. I don't really code in that style very much. So what do we need? Well, we need import data map qualified as M. And I think if we want to, we can say also like, please import the type map for me. I guess what I should do is no, GHCI, not Rebel. What am I thinking? Let's just confirm that. Yeah, so that is not legal. You can't import things like that. Whatever. Okay. We'll just write it like that. And we will say that do I want a new type wrapper or just a type alias? I don't think I need any particular fancy like instances or anything, right? So let's just say type grid of A is a m.map from coord to A. Move our input type down lower. And I could use a new type for coordinate, but I don't think there's any particular reason to not just use a tuple of 2 ints. So let's say type coord is int. Actually, I mean, in principle, I might forget which is X and which is Y, but it doesn't really matter. Unless there's going to be something special about the difference between horizontal lines and vertical lines, I can get X and Y mixed up as much as I like, provided I leave the int pairs alone. I'll just be looking at the map sideways or whatever, right? So we'll just do it like this for now. We're going to use a grid of probably list of line. So let's define then we'll use a data instead of a tuple for this one. Data line is a coord, no, line of coord, column from and to, and column, and say they're both of type coord. Deriving, I don't know, we want like show, we certainly need eq and, well, we probably don't need an or, do we? We might. They might ask us at some point, hey, which line shows up the most times or something. I don't know, seems unlikely. But who knows, maybe these type class instances will be useful sometime. And going to need import text regex applicative, which for some reason, like my HLS thing thinks doesn't exist, but Haskell interactive mode and GHCI all agree that it does, so that's fine. All right, it says like that doesn't exist. I don't know why. Oh look, I was trying to parse like all these weird, whatever. So we may as well start with a parser, right? So let's just define some regexes. Type regex of A is re char A, and then we can say coord is a regex that produces a coord, right? And coord is very simple. Coord is a tuple mapped over, I don't know, maybe let's import control.applicative lift A2, and I can stop writing. Oh, that, lift A2, there we go. Then I can stop writing all these silly lift A2 of tuple over, oh, but I can't because I want to do some stuff in the middle. Yeah, I need to throw away the comma. So it's a decimal and sim comma, and then another decimal. And a line should be pretty simple as well, right? a line is just 2 coordinates with some junk in the middle. Line is a regex for line, and line is line mapped over coord string, and then that is what shows up in the input. Act to another coord, and we will also throw away a new line. So our input parser is very simple. It's a regex of input, which I guess we have to define at some point, to be a list of line. Input is just many line. Cool. So our code no longer compiles because, hey, what do you mean decimal isn't in scope? Oh, it's in common. That's right. Import text regex applicative common decimal. And now it's just mad that, like, oh, you said input part 1 prepare produces an input, but actually it produces a list of string because that's what input used to be. So that's fine. We can fix that. I guess I could have just written. I could have included the lines here and not had to handle the problem in regex, but okay, whatever, it's fine. Prepare is really just from maybe empty list of composed with equal tilde input. Is that right? From maybe is not in scope. Import data maybe from maybe. This all compiles. Great. So one thing we can do is just in GHCI say pair of prepare mapped over read file input.txt. And it parses correctly, we get a bunch of lines. Great. Well, it parses and we get a bunch of lines. I guess we don't know for sure that it's correctly. But I have a hunch. Generally speaking, if you write a big old like regex and it matches something and it matches every character in the string, you're like, okay, yeah, I was probably right. And it parses them, right? If we're just producing strings like in some other language, you might be like, did I miss some? I don't know. Anyway, so cool. Now we have our parser done. Do we want to commit that? Sure, let's. I guess I need a new window. 5. Day 5. Parser. All right. So I don't have any idea really what we'll be reusing between part 1 and part 2. I could, if I wanted, like, one thing I'm going to need to do for part 1 is, like, iterate over all the lines, fold over them, of course, fold over all the lines, and add data about them to my map, to a grid, right? And I could say, oh, the result of doing that grid, that's my real, like, input, because maybe part 2 will want that information too. But I bet it won't. I bet it'll need to do something different anyway, because it's got, like, it's got to handle diagonal lines as well, if nothing else. Let me actually. We want data map strict. I don't particularly need any lazy maps today, right? Right. So we might as well not pay for it. So part 1, I guess. Well, let's just define a function. map. Gosh, I don't want to call it map because that refers to the functional programming map, whereas I mean like cartography mapping. Import orthogonal lines. Takes an input, a list of lines. Actually, I'll spell it out this time as a list of lines. That's kind of useful. And it produces a m.map. No, I already have a type for this. A grid of, I think, line. Import orthogonal lines is foldr. Need foldr, right? Yeah, sure. Foldr add to grid of our starting function will be not a starting function, our starting point for where the iteration ends will be. Also, I guess I should do this foldl prime. Like if I'm talking about I don't want this to be lazy, why am I building up a lazy thing, right? Foldl strict add to grid of m.empty, I think. That exists, I'm fairly sure. And I need to import foldl strict now. Import data list foldl strict. Where add to grid of my accumulator will be on the left, so that's M, and my line, this will shadow with the outer line, but I don't really care, is I now need to like foldl again over the I now have to characterize whether the line is horizontal or vertical or what. Let's just define a new type, shall we? Data orientation is either vertical or horizontal or diagonal. Deriving, show, enum, peak, or maybe I need those things, probably not. So what I need to do then, I think, is case orientation line of well, first of all, we can say if the line is diagonal, we just return M. We ignore the line completely. If it's vertical, we let vertical means the x's will be the same. X, y1, ignore the other x, y2 equal line in no, not yet. I'm not yet ready. From equals min y1 y2 2 equals max y1 y2 in. I'm sure there's like some duplication here that could be fixed. I'm going to have to duplicate this in horizontal as well, and I kind of hate it. Foldel. Oh, hang on, let me look at data.map.strict. How do you... What are the ways to insert into a map? You can just insert, yes. Insert with I use all the time. Insert with key I won't need. And is there some cool like merge that I might want? Combine union? Union with? But these all just take like a single, they take two maps, right? You need like, if you want to combine them, you need like mconcat or something. But okay, so we're just gonna fold L again. Fold L strict. Hang on, you guys can't see this, of course. Fold L strict of add point M is our initial accumulator, and now we need to generate a list of the coordinates to insert. Actually, let's just find the add point function here. Add point. Oh, it can just be from 2, can't it? Because I can use the, I can close over the x. Add point of m. I'm gonna shadow the outer m, but that's okay. My is m dot insert with m append, I guess, because I'll be putting lists in the thing. M dot insert with, what order is it you take parameters with for this? Insert with takes the combining function first, which I've done, then the key, then the value, then the map. Y X. Ah. Oh no, I have to take the M, don't I? I'm folding. You know, I was hoping I could have just put the M as the last parameter and then erase it, but all right, whatever. Oh, but I'm not inserting X. I'm inserting the tuple XY, and the value is the line. Okay, that's better. So does this compile at all? No, I haven't written orientation. That's fine. Orientation is a function from line to orientation. Orientation is undefined. Did not to do semi-group line. Ah, indeed. I wanted to add a list containing this line. And this should be a grid of line to be a grid of list of line. Okay, cool. So this compiles now. So the idea is to, what I want to do is, I could just track numbers like they're asking me to, but I thought it might be useful to know which grid lines touch each point, which lines touch each grid point. So we're going to have the value of our map be a list of the lines that are present there. And then if all I want is their length, I can just call length. And then we can say, we can do pretty much the same thing, horizontal. We're going to do basically this. And I don't love the duplication, obviously. I'm sure you're all with me on that, but it's a good way to see where you might have some, if you aren't sure how to abstract something, just implement it twice and then look at what's missing, like what's the same between the two of them. Min x1, x2, x1, x2. And yes, we could, like, I don't know, never mind. Don't worry about it. Mx, and here we can actually leave the body of this function the same. And this does all compile, except I haven't written orientation. So orientation of line of x1, y1, x2, y2, if x1 equals x2, then the x's stay the same, so it must be vertical. If y1 equals y2, then it must be horizontal. And otherwise, it's diagonal. Now, what is it that they want us to do for part 1 as the answer? At how many points do at least 2 lines overlap? Okay. So part 1 is going to be producing an int, and it should be pretty simple. It should be like count overlaps composed with import orthogonal lines. And I think that's about it. Count overlaps is a function from grid of list of any a. It turns out we don't care. To an int. What do you get when you fold over a map? Is a map? What type classes does an it should be yeah, of course. You should get the values, right? If you fold over a map, then obviously you get the values, because that's the last type parameter is what you're going to get when you use like foldable or something. So I can actually be slightly more general, and I can say it doesn't take a grid of A, it takes anything foldable, FA. And it's like count overlaps of C is probably I don't even need the C. Probably I can partially, I can do that point free. But it's length of filter greater than 1 composed with length composed with toList. Where the hell is why are you upset about parse errors here? There shouldn't be a parse error. Perhaps I meant m.toList. Well, I could, but I wanted to use the generic one. And I need f of list of a, in fact. So I think toList is in. Well, let me just ask Google. toList, is it in foldable? Yes. Okay. Data.foldable. Import data.foldable. This compiles. Well, that's exciting, isn't it? Is it right? I don't know. Let's just run it and find out. Stack run. The screen is black. Thank you. I accidentally used the wrong keyboard shortcut. Okay, I don't think you guys missed much. I wrote count overlaps, but I think that was a bit ago. And I just said that part 1 is count overlaps composed with import orthogonal lines. I don't know. I could be one of those guys who likes you just like broadcast the whole screen, but I don't really feel like that's what I want to do. I want to like I don't see super well, and so I only focus on one window at a time. And I think it's nice to make maximum use of the screen real estate. There have been like some dungeon crawl coding videos I did in the past where like I used like the top right corner of the text editor window to like show a crawl window or something. I guess I could do that. That's usually pretty empty. But sometimes it's not empty and I end up covering stuff and I don't realize it, so I don't know. Okay, so does this compile? I mean, it runs. So we got even a number. That's pretty cool. 3,990. What do you guys think? Is that right? It's the right answer. Great. So let's get that committed. First, let's just make sure this is all stuff I actually want to commit. That looks good. That looks fine. And then this is just orientation, import orthogonal lines, count overlaps in part 1. Yeah, I want to commit all that. Git commit -m day 5 part 1. Cool. So let's see what part 2 is all about. I bet we have to deal with the diagonal line. Unfortunately, considering only horizontal and vertical lines doesn't give you the full picture. You need to also consider diagonal lines. Because of the limits of the hydrothermal vent mapping system, the lines in your list will only ever be horizontal, vertical, or a diagonal line of exactly 45 degrees. In other words, yes, okay, so I wondered whether, what diagonals they might, okay. No. It's just like exactly the same thing, except you have to handle diagonal lines too. Okay. So we should be able to reuse most of the code. We're just going to have to like extract it and put it in some new functions. Right, all this stuff. Basically, we can just extract this entire function and provide it with another a blank. We only need one parameter, which is what do you do with diagonal lines, right? So we'll say, let's rename this function import lines. Takes a function from, it's a little bit tacky to take a line and then assume that the line is diagonal. But okay, I'll do that. Line to well, really what might be nice is if it took a line and gave you back a list of chords to add, right? Diag handler. And in this case, we will call, we'll do something very similar to this, right? Fold L prime add I think we can just say m.insert with, right? Fold L prime of m.insert with no. Okay, fine. We'll define a new function called add point. diag handler of line. And we need an M in here somewhere. M, there we go. Where add point of M and X and Y. We're gonna get a list of tuples in that case, right? Yes, those are the right parameters to have. Is m.insert with, I can just say chord here. Chord line M. So now I can just say import lines of const nothing. No, let's say empty. There you go. So let's check real quick that this still runs. And gives me the same answer before I go messing with it. Cool. So let's just git commit day 5 generalize add or import lines. Okay. And now we're going to say part 2, which is now going to finally return an int, is count overlaps of import lines of points on diagonal, where points on diagonal of a line of x1, y1, x2, y2 equals okay, it's actually like a little bit tricky. How do you get the list of points that a diagonal line crosses? The x and y coordinates of the 2 points are both going to differ. So this is gross. Well, we can let the length of the line be the absolute value of x1 minus x2, right? Yeah, this should be okay, I think. So let's say it's let len equal abs of x1 minus x2. Of course, it doesn't compile because the whole file is nonsense, but that should be okay. And then all we need to do, I think, is compute a delta direction, and that is like delta equal a tuple of signum of x1 minus x2 and signum of y1 minus y2. So in this way, we know kind of the step. If we were to let's actually do it the other way around, x2 minus x1, so we can think of 1 as the starting point and 2 as the destination. Well, let's... I want to be a little bit fancy here. but there's not really any. I want to use not a tuple of ints, but a tuple of sum of int, and then just use like mappend to add together the tuples pointwise. But it's gonna be weird because okay, so whatever. Points. Well, let's just say in. Scan L, which okay, it actually knows what scanl is, so that must be imported from, that must be in Prelude. Okay. Scanl, so scanl is like a fold L that also yields, oh wait, I don't want a scanl, do I? I don't know. It yields the intermediate states as a list instead of just the final state. And so what I want to do is start with the point named start, and add delta to it kind of iteratively until I've done this length times. So maybe what I'll do is take len plus 1, because these are both inclusive. They're inclusive on both ends, of iterate whatever of start. And we'll say move of xy is x plus. No, I'm not going to use this delta after all. So we'll say dx dy then is x plus dx, y plus dy. Take len plus 1. Okay, so this is like interesting. Does it compile? No. Signu is not real. Very good. Let's open this up in GHCI, because I'm not yet confident that this is correct. What if what's this function called? Where did it go? Point. Oh, I made it a private function, so I can't actually test it. Okay, hilarious. Okay. Points on diagonal of a line from 0, 0, this should be easy, to 4, 4. And we get exactly what I wanted. If I say 4 to minus 4, I also get what I wanted. Cool. And if I said, if I pass these in the other order, they should be the same, right? 0, 0. Uh-oh. Is this right? Oh, it is right. Huh, phew. Yes, that looks good. Okay. So this might just be correct. Let's try running it and see. Stack run. $21,305. It's like 5 or 6 times as big as our original number, which is maybe a little surprising, but it could be right. Let's try it. That's the right answer. Great. Okay. Well, I'm happy with that. Git add -p git commit -m day 5 part 2. Is there anything we want to review before I get out of here and go fall asleep again to rest off my booster shot? The regex thing should be pretty familiar if you've been watching these before. Orientation is a function that I'm not really happy with. It's throwing away information that we maybe could have had. right? Because, like, this orientation type doesn't carry with it any kind of proof that the line associated with it is actually vertical or horizontal or whatever, right? So, like, maybe what would have been better would be for an orientation to be kind of a delta. Oh, sorry, you guys can't see this again. Damn it. I get lost. This orientation is kind of a type without with too little information. We know something here, and then we throw it away when we do these. And we kind of just have to remember in our heads, oh yeah, that's right, horizontal lines have the same x, or the same y. See, I got it wrong already. And vertical lines have the same x. And a diagonal doesn't have those things. But I think what might have been better would be if this, like, orientation somehow did most of the work that's in our points. Oh, I didn't give this a type. Points on diagonals, a function from line to list of chord. So let's git commit dot amend no edit. So now I have a more reasonable. Okay. It would be kind of nice if this points on diagonal function could just, like, handle the deltas between any set of points. Or if there were a function like this that could, you know, find the delta for a line and the start point and the length and return that. But the problem is, like, we don't always want to make use of that, right? Here in part 1, we're supposed to ignore the delta if it's... So I don't know. I don't like it, but I'm not smart enough to figure out what I should have done instead. And this, like... Honestly, I don't see a very good way to factor out any of this. Because they're both using add point, but it's a slightly different add point. Even though the body is the same, the parameters are different. The x here is a parameter and the y is being closed over, and here it's the other way around. So, I don't know. I don't think there's a very amazing way to factor this out either. This is the fastest I've done Advent of Code this year, and yet I'm the least satisfied. Because I don't think it's a very good domain model, really. This is what I like to build. Points on diagonals, okay. All right. Oh, there was one thing I wanted to show before we go that I forgot about. Git show day for... Git show origin day for foldar states. So this is not, I think, a better implementation of day 4. But it's kind of interesting. Something that I've known existed for a long time, but only recently came to grips with, like, why it is the way it is and how to use it, is like a foldar that you can see. Like, what's interesting here, let's actually just check out this as well, and we can go look at it in Emacs. I mean, the diff is kind of more interesting, but okay, whatever. Oh, I'm in the wrong file. Yeah, this is not the right way to look at this. Let's just check out where we were before. Does that work? Am I on master? Or main, rather? No. Okay. So if I this was this function that I wrote that I don't even remember why I needed states, right? But this go function here is like folding over the states, right? There's got some list of what is it even going? What is it mapping over? So it's mapping over the input, which is no, it's go nums. I don't. Nums is the numbers we were drawing for the bingo game, right? And I also had it take as a first parameter a list of boards and then a number, right? Or a takes a list of numbers and a list of boards. And it's written as like, okay, you know, it's not a very complicated function. It does a case match on the list, and if there's no numbers left, we say, okay, there's no more states. If there is a number left, then we compute some function of like, this is this new state that I want to add. Maybe I'll do that a little bit less harshly. This is a new state that we want to add, and this is the recursive call to compute more states based on the remaining board. And that's fine, but if I didn't have this second parameter, this boards, I would look at this function and say, why have you written like go of empty list is empty list, and go of x's equals foo of x's? That's exactly what foldr does. It takes a value to use in the case the list is empty, and a function to combine the result of folding over the rest of the list with handling the current element. And that's what I've got here. And so a technique that you can use, which again, I'm not really arguing is necessarily always clearer, but like we have this extra parameter, and so we can't just call foldr, right? You would think. But in fact we can. And so you can see I'm calling foldr go of, we'll ignore this const for a moment and pretend I'm calling foldr go of the empty list, because foldr kind of wants a value to use when you get to the end of the input. And I want mine to be empty list. And then my go function is a function of 3 arguments. Whereas normally when you fold, as in, for example, all of our fold functions, these add points, take 2 arguments. What's the deal with a fold that takes 3 arguments? And the idea is a function we could have written go n ac equals lambda boards, blah, right? And then we can say that our fold function is producing, or our fold is producing a function that takes in as input the list of boards remaining at that time. And that's why we have this const thing. So if I have a function that, if my accumulator value is a function that takes in the boards remaining, then my initial value must be a function of boards remaining. And what I want to do is just ignore the remaining boards and always return an empty list. That's what I'm doing here. And so we pass a function that always produces an empty list as our initial accumulator. And then every time when we iterate, we're kind of returning a new function of boards. But because of Haskell's, the automatic currying, we can write that as a 3-argument function instead of a 2-argument function that returns a 1-argument function. And in that way, foldr handles the recursion for us. And I call ac, instead of calling, in this case, go ends with the remaining boards, I just call ac with the remaining boards, because ac is a function that takes in the remaining boards. And this whole thing about calling go recursively and breaking up, the empty list and the non-empty list points is handled for me by foldr. So, I don't know. I'm still, this is, understanding, finally, why this works is sort of new to me. I just have, in the past, seen people, write these foldrs that take extra arguments, and I'm like, okay, I get it. But what you know, what's the point? And the point is that I still don't really know, to be honest. It's about the isomorphism, like of looking at this and seeing, oh, that's a foldar, but it has too many parameters, so we'll move any excess parameters into a function. So you can fold over a list and do any, like, one foldar over a list is kind of, you know, enough to compute any primitive recursive function over that list, and most stuff is that. I think. I don't know. I'm not a theoretician. But I, like, in the past, didn't really know how to take this and think of it as a fold. And the answer is, of course. Take this third parameter and make it, turn it inside out. So instead of a parameter to your Go function, it's like, it's a function that you just return a function that wants one of these things. So you can actually do a foldar that takes like 5 arguments. If you have one list that you want to pattern match on as your first argument, and you need like 3 extra arguments here, you can just pass all of them as, I think. Is that true? I think so. You just have to pass like a 4-argument function or whatever, or 3-argument function as your initial accumulator. So anyway, that's enough for today, I think. Hope you guys enjoyed. As always, I'll leave the stream open for a bit in case people want to chat, but chat's been pretty quiet, so it won't be for too long. Hope you enjoyed. Thanks for watching, and I'll see you next time.